Hey guys, and welcome to another video. And in today's video, I am making a science video for my homeschooling co-op thing. So it's on another astronomer. You've probably never heard of her, Henrietta Swan Leavitt. I think that's how you pronounce it. And so this video will be about her, what she did, and her contribution to astronomy, and just some facts about stars, because that's what the assignment called for. So let's get started. Henrietta Swan Leavitt was born in Massachusetts in 1868 and was in a small group of women in the United States who had the opportunity to attend university. She first enrolled at Oberlin College before transferring to Harvard University's School for Women, later named Radcliffe. There, she studied art, philosophy, language, and mathematics. In her final year, she took a course on astronomy at Harvard College Observatory. By the end of the 19th century, the number of women with college degrees had increased tremendously, but there were still few professional positions available to women with a formal college education, and even fewer in the sciences. With a newfound interest in astronomy and the financial support from her family, Leavitt opted to volunteer as a research assistant at the Harvard College Observatory. Edward Pickering, the observatory's director, brought together a group of women to catalog all the stars captured on Harvard's photographic plate collection. These skilled workers weren't allowed to operate telescopes, but they contributed to the analysis of data that led to major scientific discoveries. Some of the women from this group, called computers, classified stars by their colors, brightness, and spectra, a chart or a graph that shows the intensity of light being emitted over a range of energies. Pickering assigned Leavitt the task of studying variable stars, a type of star that varies in the brightness over time. Cataloging variable stars was tedious, boring, and irksome work. Leavitt had to compare pairs of photographs recorded on plates of glass, taken of the same part of the sky on different nights. She painstakingly examined every star. Each photograph plate contained thousands of stars, looking for the smallest change in brightness. Through close observation and sustained attention, Leavitt noticed a significant pattern in the appearance of Cepheid stars, a type of variable star that varies in brightness with a regular period, the time it takes for a star to cycle between all levels of brightness. Leavitt excelled in examining photographic plates. She was efficient at spotting variable stars on each photograph she analyzed and was skilled in determining their change in brightness. She was unable to engage regularly with this work, however, in large part because the continuous health issues which she suffered from for the majority of her life. At age 17, Leavitt began experiencing hearing loss, which continued to decline throughout her life. She frequently traveled to parents' homes in Wisconsin, where she stayed while recovering from various illnesses. Because Pickering valued her skills so highly, he granted her extended leave and made accommodations so that she could work remotely. Though she worked and got paid 30 cents an hour, while that doesn't sound like much, this is the late 1880s, and 30 cents then is $11.84 now, which was 5 cents more than any other computer. On the evening of December 12th, 1921, as 53-year-old astronomer Henrietta Swan Leavitt succumbed to cancer, heavy rains fell from the skies over Cambridge, Massachusetts. Over nearly 30 years at the Harvard College Observatory, Leavitt and her stars, hidden by rain clouds, parted ways. Leavitt lived a short but deeply impactful life, during which her achievements failed to receive sufficient recognition. On the centennial of her death, we reflect on her life and legacy. 100 years after her death, historians, librarians, archivists, authors, and artists recognize and reckon with the rating and expanse of Leavitt's contributions to astronomy. Thanks to her work, thanks to the work of the Harvard Smithsonian Center for their work, more people have access to Leavitt's work than ever before. Authors, including Dava Sobel, have researched and told Leavitt's story compellingly using her astronomical notebooks and glass plates. And now, read off some star facts that needed to be in the paper. The closest star to our planet is the sun, but the second closest, you probably didn't know, is named Alpha Centauri or Proxima Centauri, which, if you couldn't tell, is like the first star of the constellation Centaurus. It is 4.24 light years away, which is 2.4925 E plus 13 miles away, which the E plus the 13 is like decimals back. This is in scientific notation, so it's just really, really big numbers. It's also 4.0113 E plus 13 kilometers away. It is 4.3869 E plus 16 yards away. It is 1.3161 E plus 17 feet away. And it is 1.5793 E plus 18 inches away. A star is made of hydrogen, helium, and it is held together by its large mass with the gravity. And without light pollution, you can see about on average 2,000 stars at night, and approximately there are 200 sextillion stars in total, which is like 6 sets of zeros, which is 18 zeros. That's a lot of zeros. It's a large number. The largest known star is named UY Scuti. I don't know how you pronounce that. It is 1,700 times bigger than our sun, which that means that 5 billion of our sun would fit in that large star. Alright, that's it. Make sure to like and subscribe.